Electrolysis. I often think electrolysis is one of the hardest topics at GCSE to get your head around because it takes so much from the first units on bonding and ionic bonding particularly, and there's a lot of very specific language that you kind of have to know. So let's spend a bit of time here just going through the absolute basics of electrolysis. So first of all, what is electrolysis? Electrolysis is a chemical reaction. Essentially, it's a name of a chemical reaction, and it's a type of chemical reaction that decomposes ionic substances. Decomposes means breaks down. So possibly the simplest ionic substance that we often talk about is sodium chloride, made of sodium ions and chloride ions chemically bonded together. So if we electrolyse sodium chloride, it's a decomposition reaction. So we only have one reactant, not two reactants. So it's not sodium chloride plus anything else. It's just one reactant, and electrolysis is going to decompose that. It's going to decompose it with electricity. Okay, and we need direct current electricity. And when we do that, we end up with two products. If it's molten sodium chloride we're using, this is a very simple electrolysis example. So if we're using molten sodium chloride, so heated up and just melted down to its pure sodium chloride, it decomposes into sodium and chlorine. So the electricity decomposes the sodium chloride. So electrolysis is a decomposition of an ionic substance, has to be an ionic substance, using direct current electricity. Okay, so do ionic substances undergo ionic or covalent? Answer, ionic. Definition of an ion, remind you, an ion is a charged atom or group of atoms. And that's one of those definitions you need to know, covered in the first unit, and sometimes a lot of people forget it, so it really is a barrier to them understanding electrolysis. What happens to substances when they undergo electrolysis? The charged ions become elements. So the ionic substance breaks down, and the charged ions within that ionic substance become neutrally charged elements. And so this equation here could easily be written down here. Let's do that just to be really clear. NaCl, the compound, the ionic compound, becomes sodium and chlorine. Put some state symbols on as well, because that's heated up here to be a liquid. That would be a liquid. These are charged ions, and these are neutral elements. Okay, so is lead-2 bromide ionic or covalent? Okay, well, lead is a metal and bromine is a non-metal, so that has to be an ionic bond. Remember, there's two types of elements. There's metals and non-metals. So there's three types of bonding. One type of bonding takes a metal and a non-metal. That's ionic. The next type of bonding takes two non-metals, two or more non-metals. That's covalent. The third type of bonding, metals only. That's metallic. So is lead-2 bromide ionic or covalent? Answer, ionic. How do we know? Lead is a metal, and bromine is a non-metal. Metal and non-metal equals ionic. Next question. What is lead-2 bromide's formula? Well, the Roman numeral here tells us it's going to be Pb2+. Lead-2 bromide, made of Pb2+ ions and Br- ions. Okay, so to come up with its formula, we have to make the Pb2+ ions and the Br- ions, the number of positive charges and the number of negative charges must balance out. Okay, so at the moment we've got two positive charges here. Bromine, if you remember, is in group 7 of the periodic table. It's a halogen, so if it's in group 7, it's got 7 electrons in the outer shell. Therefore, it wants to gain one electron, and electrons are negatively charged to complete its outer shell, so it's going to be Br-. Now, we have to get these positives and negatives balanced. At the moment, we have more positives, 2 positive there, make that a bit clearer. 2 positive there, and 1 negative. So we're going to need another negative, another Br-. Okay, so now we've got the same number of positives and the same number of negatives. So we've got one Pb2+ ion, and that's Pb2 plus ion has a 2 plus charge. And we've got 1, 2 Br minus ions. So we've got 2 bromide ions. So the formula therefore is going to be PbBr2. So explain whether lead-2 bromide, explain whether it conducts electricity at room temperature. Lead bromide, like all ionic compounds, when it's a solid, and it will be a solid at room temperature because ionic compounds have high melting points, if we remember back to the start of year 10. And they have high melting points because the ions, so the positive and negative ions, attract each other. And now this positive ion here may have given its electron to that negative ion there. And they will attract, but this positive ion here may have given its electron to this negative ion here, and they will attract. But not just that, this positive ion will attract that negative ion. All positives attract all negatives, regardless of who they've given their electron to. So we end up with a situation where we have a structure of alternating positive and negative ions, like so. That's a two-dimensional view of it. Now the reality is it's going to be three-dimensional. So it could end up being a cuboid structure. If it's something like sodium chloride, so it will go back in a three-dimensional way, like so, and we end up with crystals. We end up with crystals, three-dimensional crystals, and these things. This would be called an ionic lattice, and all ionic solids form an ionic lattice, and therefore they will have high melting points. Now, definition of a current of electricity, so let's label that an ionic lattice. Remember that, ionic lattice, high melting points. Why? Because the positive and negative ions all strongly attract one another. Now, back to this, does it conduct electricity? Definition of a current of electricity. This needs remembering. Current of electricity. Now, if you speak to a student studying physics, they're going to tell you immediately a current of electricity is a flow of electrons. And that's absolutely correct in physics because electrons flow down metals because metals have delocalized electrons. However, you speak to the physics teacher and listen to the physics teacher more carefully, they will tell you a current of electricity is a flow of charged particles. Now that's really important here because charged particles can, yes, be, e.g., they can, yes, be electrons, and they are in graphite. Graphite conducts electricity because it has delocalized electrons. Electrons are negatively charged, remember. Or, in this case, it can be ions. Ions are charged. If the ions move, you can have a current of electricity. The question here is, do the ions move when it's a solid, at room temperature, when it's a solid? And the answer is no. It's got charged particles. If they moved, you would have a current of electricity. But at room temperature, it's a solid, so no, they do not conduct. So the answer is the ions are held in the ionic lattice and cannot move. So, no movement, no conduction.